Okay, now the question specifies that you're to choose a conductor and an insulator. Conductors are materials that have resistivities much less than that of silicon, and resistors, insulators are materials that have resistivities much greater than that of silicon. Close to silicon, they're kind of in the semiconductor range, and there's no firm transition between what's a semiconductor and what's a conductor and what's an insulator. Okay. On one side of silicon, though, you know there are conductors. On the other side, you know there are insulators. So now somebody chose gold and quartz as a conductor and an insulator. Gold wasn't the greatest choice because it's not even on the list provided in the problem, so I had to go back to my intuition. I think gold is pretty close to copper, which is, I think, 1.68 times 10 to the negative 8th ohm meters. Not quite as good as silver, which I think is like 1.38. That's something like that. But let's just assume that gold is this, and if I'm wrong about that, fix it. It's not far off, if that's not right. Okay, well, in that case, we can repeat the whole thing, but the resistivity is now going to be 1.7 times 10 to the negative 8th here. Okay, so we're going to get a length that's on the order of 10 to the 8th times 1 centimeter. Now, we're also going to be dividing by the 1.7. That's going to give us something like a 6 times 10 to the negative 5th meters. Okay, and that fits. The 10 to the negative 8th would multiply this 1 centimeter length by 10 to the 8th, so we would get about 10 to the 8th centimeters, which would be 10 to the 6th meters, but we're dividing by 1.7, which brings us down to 6 times 10 to the 5th meters. That's the length. I got that by a different calculation when I did it in class, but this kind of confirms it, and that proportionality confirms it. On the other hand, the quartz, with its 10 to the 17th ohm meters, is going to give us a length of 10 to the negative 17th, because, of course, that 10 to the 17th will go in the denominator here. 10 to the negative 17th centimeters, which is 10 to the negative 19th meters. That's impossible. 10 to the negative 19th meters is a billion times less than the diameter of a typical atom, a small atom. Okay? And you're not going to get a silicon cylinder of this thickness. Okay? It's going to be a billion times thinner than anything that could be manufactured out of atoms. Okay? This, on the other hand, is what? This is about 600 miles, or 600 kilometers, okay, close to 400 miles, okay? So that's like a 400-mile cylinder of gold. That's like a gold wire, 1 centimeter in diameter, that's almost 400 miles long. You'd like to have that, although if you had that much gold, you'd probably cause gold prices worldwide to crash if it became known that you had that much gold. That's a lot of gold. Figure out what the mass of that thing would be at, at over 10 grams per centimeter, and at the price of gold, not sure what it is currently, but it's probably $50, $60 per gram. And you got 400 miles of the stuff. Okay. And of course, the quartz is just ridiculous. If you wanted to get a wafer of quartz that had 100 ohms of resistance, then it would have to have a ridiculous cross-sectional area, and you're not going to achieve that.